Hello guys, welcome to 5D FPV channel. This video is all about this drone, the pentacopter that has a pushing propeller in the back, how I build it and how I fly it, and also I will give away the 3D files, all of them that I used to make this drone just for fun for you to build. And before I get into the detail of this drone, I would like to start with how can you control it. So let's begin. In order to control the pushing motor, first you need to figure it out how could you control fifth axis on the remote controller. Yes, we have 5 axes now. And for me, I use Tyrannus and there are 2 sliders here. The knob originally looks like this. And then I use a finger adapter to be able to fine control the thrust of the pushing motor. The adapter is just 3D printing part. It's not the best ergonomic design yet, but it is so simple that everyone should be able to use it with just a little modification. I use some thick foam to adjust the size so that when I actually fly, it's going to be like this. And I need to change my holding style from pincher to be on the right hand, a thumb. I'm going to fly it like this. Next step is to set all the settings in the remote controller. The principle is that we are going to control the pushing motor as if it is a servo. There are many methods in doing it, but in my method, I'm going to use a PWM channel in the Crossfire Nano receiver because I am using the KISS flight controller. And the way to do it is to long press menu, go to the Tools folder and execute the Crossfire LUS script. And then power up the receiver. You don't need the drone right now, you just need the receiver. And then go to the Nano receiver setup page and scroll down and select a spare output channel that you are not using. For me, it is output number 4. I have selected it to be channel number 8. And then after you have selected, you can exit. Next step is to assign the channel number 8, in my case, to the right slider. And the way I do it is that go to the input page and scroll down to find my channel number 8. It may be other channel, depends on what you have chosen, and I name it as boost. The way I do it is that long press enter and edit, and then select the name you want, and then the source will be the right slider, and then go to the mixer page, scroll down, find channel number 8 in my case, and then edit it, set the name you want, and the source should be, for me, the input name boost that I have set previously. And then I have set a customized curve because the slider knob, they have a center notch in it. If you notice closely, there's a notch in the center, so the thrust will be twitched by the notch every time you move the slider past that notch. To avoid the twitching thrust, I changed the curve from a linear one, look like this, to be a curve that has a very shallow increasing thrust in the middle, around 1400 to 1500 US. And the difference is here. This is the linear graph. Notice the US value. And now I'm going to pass, yes, that notch. And then and then it's going to be like this. But if I change to be the curve like this, then the thrust value is going to be smoother, like that. It's going to be the shifting thrust going to be narrower from around 1400 to 1388. Once you have finished setting the mixer channel for the pushing thrust, then you can exit. And I have something to warn you by now, because it is a servo. The motor can spin without arming. So this is my arm switch. But then without the arming, the pushing motor can spin. So be careful. You should set protection on a switch that the logic is that if that switch is not on, then the right slider will not be working. And since there is a force that created by the pushing motor, if the pushing motor spin clockwise, there is a counter force to the drone that tends to make the drone roll to the left counterclockwise in the opposite direction of the motor direction or the motor rotation. And since it is mounted at an angle, the force affects the yaw axis too. So in my drone, the motor spin clockwise, so the drone tend to roll to the left and yaw to the right. So I have to set the setting in the remote controller to offset that force. I will show you the finished product first. This is the channel 8, the pushing thrust, and the roll axis is channel 2, and the yaw axis is channel 4. Whenever I increase the pushing thrust, the roll and yaw axis offset a little bit too. It's like a variable trim. Oh, and don't forget that if the pushing motor spin in the other way around, in this case my motor spin clockwise direction, if your motor spin in counterclockwise direction, then the offset will be in the opposite way. So under the mixer page, then you select the roll axis. For me it is channel number 2 iron. And then what you need to do, the line below here is a complete one. I will show you how to make it. What you need to do is to edit it, not edit, select insert after, and then choose the name you want, and the sort will be the right slider, the booster. In my case is the booster, and then the weight and the curve we can leave them for now, and just to make sure that the multiplex is add, and then you can exit, and there you go. You will have another line below the channel 2 line, and do the same thing to the yaw axis, which is the rudder channel. I will do it again. Select insert after, and then set the mix name you want, and the source will be the input of the booster, the pushing thrust. The weight and the curve we can leave it for now. And there you go. And then what you need to do next is go to the curve page and set 2 curves. In my remote controller, they are curve number 7 and curve number 8. Curve number 7 is for the roll axis, the iron. I set the name as B2A, booster to iron. And for the curve number 8, I set the name as B2R, booster to rudder. So the value is like this. If you use the same If you use the same drone as me, everything is exactly the same or similar. The TPS source to frame with a modification in the rear arms, then you can copy this value, and the motor rotation is clockwise, then you can copy this value. But if the motor rotation is counterclockwise, you have to make it in the opposite way, in the other way around. Then let's see the curve of the rudder, B2R curve. The value is like this. But if you use a different frame, different setup, different kind of motors and propellers, then you should experiment it yourself how much offset you need. Okay, and then go back to the mixer page and select the line that you have created under the roll axis and under the yaw axis. Let's start with the roll axis first. Select the line under the island, enter it to edit, and then choose the curve to be customized, and then select the curve that you have created. For me, it is the curve number, yeah, I have set the name B2A, booster to iron, and then it's done for the roll axis, and then move on to the yaw axis, edit, set the curve to be custom, and the curve name B2R, yes, booster to rudder, and there you go. Now every time you adjust, you move the booster, the pushing thrust, then you have the offset on the roll and the yaw axis as well. The reason why the weight value on the offset lines are not 100, it is because if I change it to be like 100, it is a way to change the degree of offset without changing the curve here. For example, if I raise the pushing throttle up to maximum, the roll offset will be around 12. But if I change the weight value to be around like 10, let's say 10, so you see clearly. And now if I raise the pushing thrust, then the maximum offset on the roll axis is only 2. So the weight value here is a way to change the degree of offset without adjusting the curve you have made. So let's move on to the parts you need for building the pentacopter. What you are seeing now is the original files of the TPS source to frame. The 3D printing parts are not related. They are there just to show you which side is the front of the drone. And the first part that you will need is this biggest part, the carbon fiber part that replaced the both rear arms. And the another part that you going to need is this part that is going to mount the pushing motor. Is the way you build it is just insert it in, and I will get into more detail of how to build it in a little bit later. And then the next part is the 6-inch arm, I mean the arm that is used for 6-inch props. And then you might need side braces as well. So those are all the parts that you will need to build the pentacopter. So now let's move on to the details of how to build it. And then when it comes to actually building it, first you should find an ESC that is small enough to fit in this area. I found that Skystars Talon32 is a good option. I attach it onto the carbon fiber frame with 2-side tape and a zip tie. And be careful because the terminals of the ESC is a few millimeters away from the carbon fiber part. So I attach a 2-side tape, a piece of 2-side tape in between them as an insulation. And then before you insert the pushing motor mount onto the rear brace, you should mount the motor onto it first, because it's going to be difficult if you do it later. So mount the motor into the mounting first, and then after you have done that, before you insert it in onto the rear brace, do not forget to put a good 2-side high quality 2-side tape onto the side of the brace, like this for example. About that. Yep. And then you peel it off, and then you just insert the pushing motor mounting into it. And then the zip tie. There are 3 sections of zip tie. The first one is here. The hole is quite large. You should be able to use and normal size zip tie for this section. For the second section, I use it to secure the motor wires, and the third section I use it to secure the mounting onto the center brace. And it's going to be tricky because you have to insert it in this way. I will show you, and it's going to be this way, and then here, and then you need to put it under into the hole here. One technique is that you should bend the tip of the zip tie first, like this, and then it's going to be much easier like that, and it's going to just move in. It's just move in there, and then you have to insert the zip tie into the hole that insert it through this layer and then this layer. So there are like 1, 2, 3, 4, 5 holes for one zip tie. So I'm sorry, but that's how I made it. This hole is going to be a little bit tricky. And then yes, it's in. Yes, it's in, and then it's up onto the top of the 3D print part. So it's a little bit difficult, but you can expand the zip tie holes if you like. And then after you have secured it with the zip ties, then it is good to go. You will have a pentacopter with the pushing motor mount. However, there is a problem in the propeller mounting, because for the propeller I use the APC 5.5x6.5 EC, the APC props. The brand is this brand, okay. And the T-Model F80 Pro, they do not fit to each other. They don't like each other, so they just there's a gap between them. Yeah, so see, there's a gap. The center half of the propeller does not reach the center of the motor belt, so we need prop adapter. Lucky that APC prop also provide the prop adapters that has M5 hole too, but then only one adapter is not enough for this combination. I need to make a customized prop adapter too. As you can see here, the bigger adapter in clear color. I cut it from the lithium-ion box here, and then it's going to fit perfectly like that. And then with the low profile lock nut, it is just enough to secure the propeller. Oh, one thing I forgot to mention, the APC prop, the 5.5 x 6.5 prop, it requires an adapter into this side of the prop too. Now it comes to what kind of motors and propellers should you use for the 4 traditional motors. Well, we need to consider about the optimal flight attitude of this pusher drone, which is about 30 degrees tilt down, where the pushing propellers is perpendicular to the ground, and most of the forward thrust come from the pushing motor. These 4 traditional motors, they are not going to do much in terms of speed, so they can be more efficient. That's why I choose this motor, the 2306 at just 1600 kV for maximum efficiency, because the 2306 size is considered to be a little bit too small for the 6-inch propellers. That is a reason why I choose bi-blades. And another reason why I choose bi-blades, because I used to use tri-blades propellers on this setup, and once I changed to bi-blades, which is a sure thing that it is more efficient than tri-blades. And once I change to be bi-blades, I cannot notice any negative performance, so bi-blade is it. And that should be all you need to know in order to build this drone. Now I hope you have fun flying it, and if you benefit from it monetarily, please consider becoming my YouTube channel member, or at least becoming my subscriber, just to give and take. And yeah, have fun flying it. Thank you for watching, and see you next video. Bye bye.